Hello and welcome to Rustacean Station. I am your host, Alan Wyma. Today we have a new special guest here. It's Daniel McKenna. The name may or may not ring a bell. He is a software developer at Emotech, but he is the, I believe we can say, creator and lead maintainer of Tarpaulin. And that is a library for, I believe it's for detecting code coverage, but I think it only supports Linux at the moment. But I believe I've seen he's working on other OSs. Let me go ahead and let him go ahead and introduce yourself.
Yep. So, as you said, I'm Daniel, and I work on Tarpaulin, which is a CLI app for code coverage in Linux currently. So I am working on other architectures because the Rust compilers now added LLVM coverage instrumentation. So I'm aiming to use that for Windows and Mac coverage. And after that, I also want to bring in ProbeRS and use it for code coverage of on-device embedded tests and have it work better with the Rust embedded ecosystem as well.
Wow. So I think usually I ask more about your background, but I want to keep the thought about LLVM, right? So I know that LLVM and obviously Rust have a very tight relationship, right? Whenever LLVM gets updated, Rust, I think, actually has to take a look and see, can we use this or not? And then they will pull in or try to work with LLVM to get it working better, right? So are you kind of keeping up to date all the time on like what LLVM is doing, or you just kind of see what Rust kind of comes out with and then work from there?
So the LLVM coverage stuff in Tarpaulin isn't yet stable. So I've been working on writing code so I don't have to install bin utils on the user's system, etc. The format seems to stay standard for each LLVM major version. So I've got it working for LLVM 12, but recently the compiler updated to 13, so the format's changed slightly. So basically when a new LLVM version comes out, I'll take the test vectors that they have for coverage and I'll use that to do consistency tests between what my code infers from the results and what LLVM infers. So I will.
I want to talk a little bit more about this, right? So I don't know if everybody's understands. I know a little bit about the way Rust and LLVM kind of work, right? So I think the way LLVM works is that you give it some type of IR or some type of bytecode, and it'll translate that to whatever architecture you want to go to, right?
Yeah.
So can you kind of talk about what that process is like and what exactly you're hooking into? I think that's quite interesting and exciting.
Yeah. So I only have like a bit of a top level knowledge of the actual instrumentation, but essentially in the bytecode, you add counters that sort of increment when they're hit. And then it sort of does this to build in some extra instructions. And then it adds in some code at the start, which deals with collecting all these count values and writing it to a file after the binary runs or as it runs. And then, so this is where actually using the LLVM coverage gets a bit tricky because you have this prof raw file with the raw profile data, like the counts and the number of hits for each count. But it only has that information. You actually have to map it back to the source code. And the information to map it back into the source code is in some extra ELF section headers or whatever the Windows equivalent is in the binary. So you use LLVM prof, I think, to merge the prof raws to get prof data, and then use LLVM cov, and you give it the binary you ran and the coverage report, and it reads the section headers to get the source code locations for the counters, and then reads the data file which has all the counters and uses that to generate the coverage report. So right now I'm dealing with the ELF section parsing and sort of going back from the counts to actual coverage metrics. And that's like the big next task to get it working in Tarpaulin.
And this could only be run on debug builds, right? Because they include all the symbols and all the kind of extra data that's probably not really required for production or release builds, right?
I think you could actually run it in release just because it generates these extra section headers and just this code that counts and outputs a file. You don't actually need the symbols, you just need the source code mapping to the counts in the elf header. So you could still have all your symbols stripped from your project. Of course, the optimizer might delete a bunch of your coverage counters. I don't know how the LLVM optimizer handles that, but it should work in release, in theory.
Okay, that's good to hear. I'm still quite new about how this kind of stuff, like you can just embed counters. So it's kind of like an extra side effect of some metadata within your binary, basically. Okay.
Yeah. So I've used a coverage tool called Vectorcast before at my old job, which was for high integrity code coverage things. And the way Vectorcast worked was it added extra assembly instructions into your binary that just sent coverage counts essentially down the wire. So it worked a lot with embedded things. So I think it had some stuff to send things down JTAG or SWD or whatever. It's all closed source, so I don't actually know how it works internally, but we had a reasonable idea.
I'm quite curious about, like, how do you actually get started with something like this? And yeah, I really have no idea how you even start something. Is this your first time ever writing something like this, or what was the process?
Yes, it's my first time ever writing a proper developer tool, and even anything involving code coverage. So I'd started writing Rust and doing some hobby projects and trying to set up things which I had set up at work, like code coverage on CI, etc. And I found kcov was a bit hard to use. And someone wrote a Rust blog, Joseph Kane, about writing a debugger in C and Rust. So I kind of looked at his blog and I was like, oh, code coverage is basically just a debugger, but with less stuff in it. So I sort of used that blog as a starting point, which got me so far. Like it worked with single-threaded things, but it didn't work with like dealing with multiple threads, and I had to fill in some other gaps. Both kind of myself, like looking at things like the GDB source code, the kcov source code, trying to see how they were wrangling ptrace to do things. Ptrace being the process tracing API for Linux. And Cybrand's a C++ programmer, also has a blog series on writing a Linux debugger, which has like 11 different parts and is all very detailed. So I also use that as some reference, and just all came together.
So is it just, okay, so basically it's something to scratch your itch at work, right? That you started down this process, if I understand correctly.
It was like trying to mimic things that I had at work, but for home projects in Rust. So.
Oh, okay. So this is not even for work. This is for your own projects. So because the work one, you're using the vector one, right?
Yeah. This is for my old job. So I used to work in aerospace and defense and like doing high integrity things. And it always sort of annoyed me that like you spend like 6 figures on these software licenses for things like Vectorcast. And a lot of the time there's no good open alternative, or there's a good open alternative, but people don't trust it. So yeah, that kind of inspired me.
Okay. So, so you went through, you saw some blog posts that kind of got you started. Is there a reason why you only chose Linux, or is that because it's really a limitation of per type of platform? And also, I'm guessing you must be using Linux, or else that wouldn't make sense for you just to focus on that.
Yeah. So like both those blog resources I mentioned, they use ptrace, which is a POSIX API. So it's not on Windows. Windows has their own API. And also to stop things like reverse engineering, Apple have basically partially implemented ptrace and made it essentially not work properly. There's a different API in Mac, which is like debug ports, I think, which you're meant to use instead, because ptrace is kind of horribly broken on Apple. And you have to like sign your binaries, which I borrowed a friend's MacBook and I tried to do. but I just couldn't get it to work, and I don't use Mac, so gave up on it.
Yeah, which is, I was a little bit sad. I thought that, Mac makes a big deal that, oh yeah, we're actually Unix certified since Leopard, and we use POSIX, but then now I feel like they're lying to me if you're telling me they broke ptrace just to stop this reverse engineering. Yeah, so when I was going through Luca's book, and we got to that part, and I said, okay, cool, I can run this Tarpaulin, and oh, it only works on Linux. Okay, what a drag.
But you can run it in CI, so there's always that.
Yeah, but I already cargo installed it, so I was a little bit upset about that part.
Oh.
but nonetheless, I mean, okay, what can I do? It seems like if I want to get really into Rust, maybe I need to switch to some other Linux distro. What kind of Linux distro are you actually running, by the way? I'm guessing it's maybe Arch Linux?
So on my home machines, I run Fedora just because it works nicely out of the box. For work things, I have Ubuntu just because that's what my colleagues use. So I like to try and keep systems consistent.
Do you find much of a difference between them when you're using Rust?
Not when using Rust, no.
Even when installing Rust? I guess it's pretty straightforward, right? Always cargo install. Rust up install.
Yeah, it's pretty much just all the same on any Linux I've used, which is nice.
I'm actually kind of curious, just curious in general. Like if I build a Linux binary, it'll actually run in every single version of Linux, like different distros and also different kernels and all that kind of stuff.
Pass. I guess it depends if you link to any dynamic libraries, like say libc, because obviously that can complicate things a lot. And libc is a bit painful. It's kind of hard to have multiple versions on a system.
Yeah, I was listening to so I'm on another podcast, my own podcast, and we're talking about Flutter and on Ubuntu, and I think I asked the question how do you guys solve the issues of certain libraries, like you said, linking across, and how does that work? And I guess they basically solved it by using something called a snap, which I guess maybe you may or may not be familiar with that. Do you think snaps would actually kind of solve any potential issues if you can just snap your program, because you can just link whatever you want to link in there?
Yeah. I have used snaps for a few things which have been a bit harder to install. But I know there's complaints about system bloat, because I don't think snaps right now, if two snaps have the same dependency, they won't use the same one, which you get with system things. They'll have their own copies. But memory's cheap, so I guess it's fine.
It's more about storage, right? So storage is cheap. Just want to make sure, because memory could be confusing, right? If you're talking about a hard disk or memory.
Yeah, sorry.
But memory is still kind of expensive sometimes. If you buy a Mac, at least you want to add an extra couple of gigs, it's going to cost you. So they saw that stuff on the board. But okay, so all right. So you're saying, I think you mentioned earlier that with LLVM 13, which is what Rust is going to be or is on now?
Is on in nightly, I think. Not stable, I think.
Okay, with that one, it'll actually be easier, or at least possible. I forgot how you said this, with Tarpaulin to run on other distros, other OSs.
Well, once we get the LLVM coverage sort of passing stuff in Tarpaulin, it'll be possible to run on other OSs, but we need to implement that. We'll need to finish implementing it.
So this will solve even Windows and Mac?
Yeah, Windows and Mac should work fine.
And it sounds like you said embedded. Basically anything LLVM can compile to, is that right?
Embedded's a different thing after the LLVM. That's the next big project. Because embedded Rust has something called ProbeRS, which, have you done any embedded stuff?
Well, I mean, what is embedded, right? Basically no OS, right?
Yeah. You can have embedded OSs, but yeah, so, all the stuff I do is normally bare metal, but there's...
Yeah, so, no, I have not. I think that also counts, what is the name of that? There's some famous, it's not like a Raspberry Pi, but it's similar, right? But it's like no OS. What is that one called? It's very...
Arduino?
Yeah, Arduino. Yeah, that would be an embedded system, right? No, I haven't yet, but it's pretty interesting. I would love to take a look at it.
Yeah, so for embedded outside of Arduino, I'm not sure how Rust AVR is doing, but you didn't have Arduino support on Rust at least a year ago, or it wasn't very stable. And also Arduino doesn't come with a debugger, which is a different issue entirely. But like using the ARM chips, like the STM32s, if you did stuff in like open source, you'd normally use something like OpenOCD, which is Open On-Chip Debugger, which deals with sort of setting up a GDB server between your embedded hardware and doing it over your programming lead, like USB or JTAG or whatever. But OpenOCD, like a lot of vendors end up like patching it for their boards and changing it. So if you do like a lot of embedded, you end up with different versions of it just lying around on your system. So in Rust, they've made ProbRS, which is like a debugging library for embedded targets, like plugged into your PC. So you can run your code on the device and you can debug it on your actual computer. And it's got a library interface. So I plan on using that library interface to actually run the code coverage tests on the device. Because, I mean, at least in like safety critical things, there's like a whole swathe of robustness levels where you actually have to do your code coverage on device. You can't like stub out your hardware functions and run it on your machine.
Okay. Yeah, I was always kind of curious about how people can debug systems and write code for systems which they don't actually, they can't actually run on their machine, right? So do you know how ProbOS actually works and how it actually connects? Because that's pretty interesting.
So I have a vague top level bit. I'm not sure if you released a video for this, but I actually have a bunch of dev boards on my desk. So if I just pop out this, like if you look at any of the STM32 nuclear boards, so you have this board here, and then this chunk, like at the end, is where your actual software runs, etc. And the end of the board where you plug the USB in to program it, this is actually a debugger. So it has stuff to basically communicate with this chip, stop execution, sort of see where you are in the code, what variables are, and send that back to the computer using some protocol. Like I think SWD is an ARM one for software debugging. There's JTAG, I think, has things. And then this kind of, I'm not sure which one you count as the client of the server. I guess this would be like the server. And then on your machine, you'd have some software running which understands the protocols that this board talks out in and deals with sending it commands on what to do, etc. So you do like still have the debugger, but you have to create dedicated hardware for it.
Okay, and you're saying with LLVM 13 and even with ProbOS, you could theoretically run your code on this board and then check it, or am I remembering wrong?
Well, LLVM 12 and 13, you can do the coverage stuff with Rust. You could maybe, so ProbOS is a separate project, and that's what I'd use for doing this. But actually, you can maybe get LLVM code coverage working on the embedded board. The issue is that the function they write to generate the coverage counts and the data, it writes to a file on the local file system. And obviously, you don't have a file system on an embedded board. But I think you could maybe relink the function which they use to write that, because it's kind of public knowledge what the symbol is, and I think it's been constant while coverage has existed in LLVM. But you could maybe write your own implementation of that function, which sent data down the wire to the PC. But I've read something in one of the LLVM mailing lists with someone asking if this was possible, and someone saying it should be possible, but no one's done it yet. So who knows? Like maybe that would be the next big challenge
for yourself, right?
Yeah. If no one gets there first, like I can't promise I'll even look at that this year, but like if it's not done in like a couple of years' time, I should have time to do it. In theory.
I'm kind of curious, like, because we're working with LLVM, right? for things like Swift, which also can run natively on other machines because it does LLVM, if I remember correctly. I mean, couldn't you kind of like rewrite some of your projects so that you could possibly donate it to other projects, or like saying this is the LLVM code coverage tool, or at least this is like the LLVM piece. This is how you connect to it, and then you can like split apart your project and have a Rust piece that you're kind of maintaining.
I mean, you could. So there's I think like the easier way to get it just working general for all the tools, which some other people have already done, is to like write a shell script or a Python script that calls for different LLVM binaries and handles setting the compiler flags, building, ingesting the reports and using it. But you could write a bash script to do that quite simply. So I mean, obviously I'm doing it all in Rust. I'm trying to minimize like having to install other dependencies and do that whole dance. The other stuff that Tarpaulin gives us value apart from instrumenting and collecting the coverage in different ways is that it understands how Rust projects are laid out, so you can deal with enabling your features. It does some source code parsing, and like you can easily ignore your tests and it will look for things under like test configs and remove them from results. It will filter out some Rust language constructs which don't actually generate coverage but can cause false positives. For example, when I first started, the derive macros above structs would show up as uncovered lines. Like, I filter them out. So I don't think the LLVM bits, like, I don't think there's too much benefit in releasing the Tarpaulin stuff for other languages, but I am making like my parsing code for it outside of Tarpaulin in another crate. So people could use that other crate if they wanted.
So I share with you the notes, and I was just looking through, and I did see you write. You have actually had to, I believe the right term is yak shave, right, where you have to actually add things and create things before you can do what you originally set out to do, right? So what's some of the other supporting projects you had to work on in order to get where you are today?
Oh yeah, so when creating Tarpaulin, because obviously you're interacting with the compiler, you're setting Rust flags to keep in things like dead code. When you do that on other people's projects, things can sometimes interact differently, like especially if, say, someone includes some native code or they're using Cargo-kcov, like there's so many different variables. So I've created Tater, which is like Crater, but for Tarpaulin, where I have lists of GitHub URLs for projects, and it will download them, and it will run Tarpaulin on the project, and it will look for any failures, and it will store debug logs, like the actual logs printed out, the coverage results, and I can use that to basically run Tarpaulin for a ton of projects automatically and try and figure out if I've broken anything, just like Crater does with the Rust team. The only issue is that I run it on my laptop, so like the target directories, I didn't delete the target directories initially, and I used up all my disk space after 3 hours. So I've had to be a bit smarter and not store quite as much data. And another one, I have a project called Tarpaulin-viewer. So when you're running the tests and the tests have multiple threads going, and you have these ptrace events firing, like the sig stops when it hits a breakpoint. Those can happen on any threads, and multiple threads can access the same instruction at once. So setting and enabling breakpoints becomes a bit of a multi-threading issue because you've also got a shared address and multiple threads accessing it, and you're trying to change the breakpoint. So I had some issues quite early on in Tarpaulin with seg faults caused by hitting a breakpoint, disabling it, doing step to move the code point on after that instruction so it executes it, and adding back in the breakpoint, and then another thread which was like on that instruction but I hadn't moved would be stepped into the middle of another instruction and get like a sigil or a seg fault. So I made Tarpaulin-viewer where Tarpaulin can write out a sort of big JSON formatted log file of every event it gets in order and like what the breakpoint state is. and I can load it into Tarpaulin-viewer, and I can basically see like a timeline of events and where all the forks are, where all the thread spawns and thread exits are in a test, and how Tarpaulin's interacting with that. I did initially like write a script to just generate an SVG file or like a graphviz file really quickly, but I was running it on a project with a few hundred tests, and the SVG was so large that I couldn't find anything that would render it without crashing. So I ended up having to make Tarpaulin-viewer just so I could actually just generate it using some graphics on the fly and just render what was in view.
So this is Tarpaulin-viewer, right?
Yeah, it's in C++.
That's what I was going to mention. I was like, this is interesting. It's C++ though. Why did you choose C++ for this one?
So I used, at my old job, I was pretty much a C++ and C dev, and I do maintain that like I've used a bunch of different GUI frameworks across different languages, and Qt is the one which I am most productive in. And I think when I started Tarpaulin-viewer, like I looked at some of the Rust GUI options, but I wanted kind of a canvas and like a scene graph with view culling, and I don't know, Rust GUI didn't seem quite as productive for me as doing it in Qt would be. So I just wrote it in C++.
So this is using Qt, but I think Qt you have to pay for, right? Or that depends on what you're doing with it?
Not if it's open source.
Okay. All right. I didn't know that. I do, because I remember I used Rust as a backend and just exported out DIL files for Windows, and I think just linking in a static library for Mac. And I was using Flutter for the GUI. And we were looking at other ones, and we looked at Qt, and because it's a commercial company, right? That's why they were like, yeah, we really can't go down that path.
So, yeah, if you want to sell anything with Qt, and from what I recall, our licensing terms are like it does cost a lot to sell a Qt project, but for open source, and I think there might be allowance for companies if they're not selling or using it for business, but using it internally. I think they can use it for free, but as long as they don't publish distribute their binaries or anything. I'm not 100% sure on that. Like,
do you think about ever maybe rewriting it with like ImGui or some of the other ones I've seen be coming out recently? Because I think things have definitely changed in the, like, look at arwegui.rs, I think, or I think it's what it's called, arwegui. It seems like things are progressing, right? I think ImGui is definitely up there, and then there's another one that people are pushing, but now the name is eluding me. But it's ImGui or something, ImGui.
Oh, yeah.
Those seem to be the two biggest ones I think people are pushing nowadays.
Yeah. If I ever need to do a big change on Tarpaulin-viewer, I'll probably look at if I could rewrite it in Rust. But it's been fairly stable, and I haven't had to do much on it. So, I'll just happily live with the C++ for now.
You don't ever feel nervous that maybe you might do something wrong that Rust maybe would catch you on?
I mean, it's such a simple and small app that I'm not too worried. And it's also not critical, like it's used for my internal debugging purposes. So if it seg faults, like it just annoys me. It doesn't actually bother any users.
I was just thinking how many times have people said that before. Oh, it's just some small project, not really need to worry about anything.
Yeah. I mean, I've got bigger C++ in my life I worry about.
Well, nobody wants to be the guy who makes another heart bleed, right? So, but I understand too, right? This is not really a critical and not really something that's everywhere. It's mostly just for yourself on your own machine.
Yeah. I mean, if anyone does start relying on Tarpaulin-viewer, like in production, I'd be scared of that person.
Okay, so even yourself, you're just like, yeah, it's not a good idea to use my code in production.
I mean, not like, if you're using some internal debugging tool for some guy's open source project in production, which has no tests and is written in C++, like, you must like to live life on the edge.
So did you drop an MIT license in there just to kind of cover yourself?
Yeah, I think I did. I normally try and stick a license in everything I do, just because, everything is licensed in some way. Did I? Oh no, I didn't stick a license in it. Oh no.
I think I just saved you a lawsuit.
I'll be doing that after this then.
All good. I'm also looking at your NN visualizer, right? Because I did some research on you. It seems like you're kind of also into data science too. Am I wrong?
Yeah. So the current startup I work at, say AI startup, and I don't do much research myself. I mainly work on taking the researchers' systems and creating Rust backend services for them.
Okay, so you're in the AI space. Okay. Okay. Yeah, it makes sense to use Rust with AI because it's pretty quick, but I think they're still developing a lot of the pieces, no? Because it's not like Python, but or you're just kind of digging into C or C++ things to kind of supplement.
So we're using TensorFlow and the TensorFlow Rust bindings, and there are a few crates around. Like if we want to do something like clustering or hidden Markov models, we'll either look to see if there's an existing crate, or we might just implement something ourselves using Ndarray.
I think Ndarray just came out recently, or has it just been more used recently? Because I just seen it pop up.
Yeah, it's been around for quite a while. I'm not sure how long it's been around, but it's recently had like a flurry of activity, like during 2020.
Oh, so everybody's at home, so they have time to work on this, I guess.
Yeah, possibly. Yeah, actually, also, I was just going to say, when I first interacted with Luca, who wrote Zero to Production, he was doing a lot of stuff on Ndarray, and actually first like properly interacted with him, I think, on the Rust machine learning code stuff.
Okay, you guys are both in the same space then, you're saying.
Yeah, well, I mean, not now with him at TrueLayer, but before he graduated, he was doing more machine learning stuff.
So do you think, I mean, I guess you do think this, but you always hear like Julia, Python, R, these are the languages for machine learning now. Is Rust actually, I think, a real competitor with these languages in terms of machine learning?
I think, like, in terms of researchers doing research, I don't think Rust really has anything. Like, researchers don't like writing Rust. I can tell you this from experience. So there's not really much competition there. A lot of the Python things have C++ backends, and for new libraries that pop up, that's potentially where Rust will shine as being alternative for writing your C++ backend and doing bindings. For production systems, especially on like the ones we work on where we have some hybrid systems which aren't just neural networks, there might be other statistical models. Using Python in production wasn't really a go because the source of data, like obviously everything's really fast when it's in NumPy because that's all C. Everything's fast when it's in TensorFlow because that's all C, C++. When you want to push data in, get data out, and do other processing on it, you can sometimes get hit by like unexpected big data copies that really hit your service performance. And that's where Rust is nicer because you can actually control your memory a bit more and you can guarantee that you're not doing these copies. And I can move from TensorFlow to Ndarray using zero copy code, just using references and lifetimes. So I think Rust has like a lot to offer in sorts of production machine learning systems, especially ones that aren't end to end.
Okay, that makes sense. I'm also kind of curious, like, is there ever an issue where like new Rust versions will cause you any problems with Tarpaulin, or because of the way that Rust is quite stable in terms of writing your code and kind of works for forever, that you don't really have this kind of problem?
Sometimes changes in Nightly have caused me issues. There was one change on incremental builds earlier this year where I think it was to do with a flag. It was either like the dead code flag or a dynamic relocation one, but there was some change in Nightly, and one of those flags, if you changed it, it wouldn't recompile those parts. It just thought it could incrementally use the previous ones despite the linker flag changing. and it would cause I think it might have been an ICE, actually, an internal compiler error. But basically, as soon as that nightly update came out, it's like Tarpaulin spotted it instantly because it changes for Rust flags, and it hit this issue directly. And I just raised an issue in Rust, and they reversed it for change, I think, that week, and that fixed it. But yeah, sometimes there's small things like that, but otherwise, like, that's rare. Like, probably happens like less than once a year, I think.
I think I remember hearing in the previous version that there was a couple patch releases out, and then one of them was to fix an issue with incremental builds, and for some reason it was causing issues. It sounds familiar with what you were talking about, but maybe I'm relating two different things.
Yeah, I think they're both different issues, but in the same source of parts of the code. I think the other one was a soundness bug, but I can't remember why it was a soundness bug. Whereas I think this one just caused linking to fail because of incompatible flags. So you didn't even guess a compiled binary.
Okay, got it. I'd like to kind of go back. Like I said, we usually talk about kind of where you come from. So what was your kind of start into programming, actually?
So in the UK, when I did my A-levels, that's 16 to 18 education, it was the first year where there was an option of a computing module, which taught programming. So when I was 16, I learned Pascal, begin and ends instead of braces. Instead of void as a return type, you wrote procedure and you had to write function for you functions. It's quite old-fashioned. It's an interesting language. And then the next year, we're meant to do an object-oriented language. And we're meant to do Delphi, but the school couldn't figure out how to install the compiler, so we did Java instead. And then from that, I went to uni to do a degree in AI. So mostly computer science, but with some added statistics and neuroscience and machine learning stuff added on.
Why did you decide to go to AI?
So I went for AI because I've been going around like different universities looking at computer science, and a lot of the computer science unis were, I don't know, like, it wasn't that engaging for me. They were just talking about like web apps and Java backends, and like it all seemed like very enterprise software and maths. And like maths is mildly interesting, but I wasn't as into it then. Then I went to Reading, and they had a cybernetics department where they did it was part of the computer science department. They also had a big robotics and AI research group. And there was things like computational biology, there was robotics and control systems. It just seemed a lot more interesting to me than what I was seeing at computer science labs. Maybe it's because I saw like an inverse pendulum robot, and one of those ones that like goes and just stops before crushing an egg, and big robot arms, and they had a Dalek which could put out fires in the lab. I think I just got attracted by shiny things.
Yeah. Okay. I find it kind of interesting because with Tarpaulin, right, I don't think it's so much AI unless I'm wrong. So it's kind of like a little bit off the journey, but definitely something you're interested in. Do you think you're actually going to keep working on this project for quite some time?
Yeah, I think, I've already been working on it for a number of years, maybe 4 years this year. I'm not sure. I'll have to check. Yeah, I can see myself working on it for quite a while. The whole code coverage thing really just comes from going from AI. At my degree, I did a lot of C++ and some embedded and controls. And I went to aerospace because I thought I could maybe learn to design flight control computers and the control systems there. And I thought they were potentially very interesting. Like, it seemed like one of the few areas where verification could be really interesting, like safety critical things. And there I got introduced to code coverage and the source of coverage requirements of things like flight control computers. And I guess that's what planted the seed in my head.
Mm. Is there any like long-term goals for Tarpaulin?
Just get the LLVM code coverage stuff going, and then the next long-term goals, the embedded coverage. After that, I'd like to see if I could use the LLVM coverage to get more exotic coverage metrics, which you can't do with breakpoint-based coverage. So, I mean, right now, Tarpaulin just offers line coverage. I'd like to go on to branch coverage, which you could do with breakpoints. Condition coverage, which would be hard. And MCDC coverage, which is modified condition decision coverage, which the only time I've seen MCDC coverage used is in aerospace and automotive. So I don't expect people will actually want to use it, but it might be very nice for getting Rust into more safety critical systems.
Yeah, I definitely think so. You are using Rust at your current job, right? And
Yeah.
but you did not use Rust at the aerospace place, right?
No, partially because it was impossible to use cargo there because there wasn't cargo offline at the time, and because of like all the firewalls and all the security systems in place for a defense company, any package managers basically just did not work.
Yeah, you'd figure you'd be able to somehow self-host or a mirror somewhere. And I saw something on Twitter recently where somebody was like, "Oh, all the package stuff on Cargo is only like I forgot they said I don't know how many gigabytes it was, but it wasn't a ridiculous number, and like they put everything to memory and we're just grepping through it for fun."
Oh
Have you seen
yeah,
that?
yeah. Mara with her insanely powerful PC, but yeah, it was because I think she's got 64 gigs of RAM, and
Yeah, I was gonna say 60 gigs. It's like 60. I thought it was only 60 gigs or something. It was like a number that was pretty low when you would think about it, but it was
yeah,
doable.
yeah. So I had because at the time when I was in my previous job, cargo vendor didn't exist at the point. I don't know if you remember, but people were using cargo airplane to try and do the same thing because it was like airplane mode for cargo. Because I know someone who got basically built their project on their home PC, zipped it up, put it on the USB, and took it in. But then whenever they wanted to update that project or change something, they had to take it out on like an encrypted USB, take it home, do it at home, and then take it back in.
I think that's how people get hacked, right?
Possibly. But the company had these special encrypted USBs, which were the only ones you could use on site. Like unencrypted USBs wouldn't work. So he got a USB from a security office, and I guess you have to trust that their vendor hasn't let their USB firmware be Stuxneted.
Okay, it's very interesting. But as a developer who's worked in some regulated places, you're the same, right? With aerospace, that's obviously very
Yeah.
regulated. You can understand frustration and I'm sure you guys probably did some things that were maybe not the best at certain times in the name of maybe being more sane or actually getting something done because of whatever rule that may not work properly with what you need to get done.
Yeah, there was. So I mostly worked on like research projects when I was there, like new product development. Basically a lot of the IT rules sort of got slightly skirted past. My last project, the one which actually drove me to leave, I had to do everything properly and by the book. And I'd gone through a 4-month IT request process to be able to plug a new dev board into my PC via Ethernet. And I didn't even get the board plugged into my PC via Ethernet. Like I was 4 months in, and I was like asking the IT guy, like, how do we push this forwards? And he's like, oh, it's got to go to head office now. You'll probably expect to hear back in about 5 months' time. I was just there like, no, because I'll be gone by then.
Or you already put in your notice, so that was it, right?
Yeah.
So whoever gave you this project to do, like, I'm guessing you reported back to them, and or they're like, well, just like enjoy your last bit of time here before you leave.
Yeah, they didn't realize how painful the process was because there was a new process brought in, and they didn't realize that a lot of people were skipping steps of the process because there wasn't the necessary protections on the PCs to stop people skipping certain steps. Like the IT guy said to me, "You're the first person to make it this far." into. It's like, oh, great. So I remember leaving them with like a giant flowchart of all the steps, which IT didn't have documented. They like to keep this hidden from you just to stop you being too efficient. But I left them with like a big flowchart of the steps and CC'd them on all the emails and basically went, this person, like, respond to them next time. And I honestly don't know what happened with it. I'm not at the company anymore, so I'm not allowed to know what happened with it. But I hope they reformed the process and sped it up a bit.
That reminds me of when we were tasked in the bank to create an iOS app for basically the C-level guys in the bank, so they can take a look at the high levels about their accounts and everything. I think we were the only people who actually got a iMac brought in, because everybody uses Windows, right? So we had an iMac brought in, and everybody, like, how you do all this stuff, and I was able to figure out how to get the app working and how to get the USB unblocked and how to get the Mac plugged in. Like, I documented the entire process. So your journey kind of reminds me of what I had to do. And I also looked at like a god after, talking with Switzerland, talking with India, talking with Poland, Russia, Ukraine. Like, the divvying of responsibilities is just amazing. And it's amazing to see, like, oh, no, for this thing that you would think is one step, it's actually like 10 mini steps, and everybody has their own silo of that step. It's just insane. And another insane part was that because of bank rules, like so I literally passed up 2 Apple stores on the way up to the office every day. And we actually had to order a iMac from Japan and have it shipped to the office because that's the company rule. Which I thought, okay, that's a little bit weird, but all right, well, not my money, but interesting.
Yeah, we also had the same thing with approved suppliers. But even for research projects, they wanted us to use approved suppliers. But there was a guy who had access to the lab tools budget, and he was allowed to buy things off Amazon or Farnell or like online stores, because lab tools were seen as not products. So it was a bit more easygoing. So there were some times when engineering were basically there, like, we're going to use the lab tools budget to buy something for this project because otherwise we won't be allowed to buy it.
Yeah, I'll never understand this stuff. I mean, but you know for sure that it's somebody needs to justify keeping their job. That's what I feel is most of this kind of steps. If you don't mark out your territory, then you may not be sticking around for any good reason.
Yeah, I think there's some instances where, like, obviously, like in defense and aerospace, regulation is important because ultimately these are people's lives. But like if a plane falls out of the air because someone's bought like a resistor which wasn't graded properly or something stupid, like, obviously that's where regulation's important. But I think that's the point when you're not working on things which are going to customers, when you're working on internal tools or things that won't go anywhere near any safety critical code, where they just like over eagerly apply the same standards they'll apply for like a 777 flight control computer to me wanting to pass some log formats easily.
Yeah, I mean, this is kind of a tricky subject, right? Then there's also been, once you start kind of giving some leeway, then the question is like, when do you start? When do you stop, right? Because, okay, this is not a dev machine anymore. This is something that's kind of QA, right? So if you have a QA airplane or something, I don't know what you guys do, but maybe something that may be put into production someday, or maybe somebody actually tests it for real life. And yeah, but that's another subject. I think we've went through basically everything that I was hoping to get through. Is there anything else you wanted to chat about before I ask you a couple of last questions?
No. Go ahead.
I think the biggest question I have is somebody who's really digging deeply into this language, right? And it seems like you've been working in it for a while. Is there any kind of tips or tricks you would give to people who are maybe just beginning in Rust or maybe kind of struggling with it?
So I think it depends what language you come from, because obviously I come from C++, so I found a lot of the Rust concepts, like moving, quite intuitive. So The tip I give researchers is to read the compiler errors because sometimes they don't. And I try and I show them all the tooling available, like RustDoc, Rust Analyzer, like getting Rust Analyzer in starts to help them a lot. And yeah, just look at the wealth of resources available because there is a lot of stuff out there, and there's also a lot of people willing to help. There's things like the Awesome Rust mentors, which Jane Lusby started. So if you're new to Rust, you can actually find someone who's willing to mentor you, who's more experienced at Rust. So I guess just lean on the tools and lean on the existing documentation in the community because it's all very helpful.
And I think the last question I have is, what do you use to code with, right? Are you using IntelliJ or are you using Rust Analyzer with VS Code? Like, what's your kind of setup?
Vim. Just Vim. I keep meaning to try and get Rust Analyzer and install it in Vim, but like when I was doing C++ at my old job, there was no working code completion at all. So I kind of spent like 4 years coding without any autocomplete or without any hints. So I just got used to it. So I just use Vim and no plugins.
It's probably the best way to use Vim because when you start adding in plugins, you may run into into something.
Yeah. I mean, I want to try and add the Rust Analyzer one to see like how much it can improve my life. But I have the 2 monitors set up, so I always have the documentation up on one monitor and my code on the other. And it is a place of comfort for how I work. Like maybe there's better ways, but I just haven't taken time to experiment with my workflow too much recently.
I'm kind of curious. Like, did you ever rebind your? I forget what that deleter key I think it's called. Because for me, I think I bound mine to JJ or JK. I can't remember which one. Did you ever rebind your key?
No.
You're using everything default.
Yeah. When I had to do it on Windows, I think I rebound the Control W and then HJKRL to move between tab splits. I just changed that to Control H, Control J, Control K, Control L. I think that's the only time I've rebound anything in Vim.
It's probably pretty good because every time you have to log to a server or something and you won't forget your stuff. Your dot files are like gold, right? When you set those things up. So better just go default if best.
Yeah, that is true. It does give me an advantage when I go into servers. Although, like the one luxury I've truly given myself is I have a font with ligatures. So if I'm like editing a file on the server and I don't have my ligatures, I just look at the code and I think this looks so ugly. Where are my pretty arrows?
Yeah, I really hate ligatures for me because sometimes it disguises what the keys are. Because of course you know what they are, right? But let's say you work with a guy who's new and maybe like I've seen like the famous like not equals to where it's a bang and equals sign. Maybe you put it like an equal sign with the thing and the guy be like, well, how do I even write that key? I mean, so that's what you got to be careful about. That's my own thinking at least. Or sometimes people will change the ligature to something even weirder, like maybe like a smiley face or something for whatever key. I've never seen it, but I think I've seen something similar, but you know what I mean?
Yeah, if you look in languages like Haskell with ligatures, you get like a lot of math symbols. And yeah, I do, being not familiar with the language, I obviously don't know what all the operators are. So I'd have to look at my font to see what the ligatures were. So
what font they're using for ligatures? I think there is one famous one that I remember being on Changelog podcast a while back. Is it the same one?
Probably FiraCode. It's like, I think FiraCode is the one which most people go for.
Okay, I found it. Yeah, it might have been this one. I have to look it up, but yeah, I didn't actually know what this stuff was until recently, and yeah, I don't know. It freaks me out too much when I see it. So people are like I think it's a love-hate thing.
Yeah, definitely.
Yeah, that's the one. I think I remember this guy's he was selling his font or something for some amount of money or something. Maybe I'm confusing somebody else. In any case, yeah, okay, so FiraCode. Oh, it's interesting to hear because you're the only one I can think of that's not using like a VS Code or something. For me, I like to use IntelliJ. I like the sensor, all that kind of stuff.
Yeah, this is really a side effect of my old job still using Visual Studio 2005. So, like, I'd hit Control Space for IntelliSense on Visual Studio, and it would start re-indexing the code, and the suggestion would pop up like 3 minutes later.
Okay. Then if there's nothing else, I think it's great to have you on. I would love to have you back if you make some more changes. Maybe you can talk about the multi-platform support and how that's been. Other than that, again, thanks for coming on.
Yeah, cool. Thanks for having me.